In this video, I'm going to show you how to do a percent composition calculation. Before I go through how to do that, I want you to keep in mind that this is a mass percentage or percent by mass of an element in a compound. So how we do this calculation is we're going to look at a specific element, one element at a time, and compare the mass of a certain element in a compound to the mass of the entire compound. So how we make that calculation is we take the mass of that one element divided by the mass of the entire compound, and then we multiply by 100 to get a percentage. Now, these are both mass measurements. It doesn't matter which unit you use. You could use AMU if we want to talk about particulate level, very small level, or grams per mole if we want to talk about large level. Either way, those units will cancel out because they're a numerator and a denominator of a fraction. So I'm going to leave units off because it doesn't really matter what the units are. Let's practice with an example. Let's calculate the percent by mass of carbon and carbon dioxide. So the first step is to determine the mass of just the carbon in that compound. Then the second step is to determine the mass of the carbon and both oxygens in the compound, or the mass of the entire compound. The third step would be to multiply by 100% to get that percentage. So let's look at the mass of the carbon, 12.011. That is the atomic mass of carbon, and there is one carbon atom in carbon dioxide. So 1 times 12.011 is my numerator. That is the mass of just the carbon. The denominator is going to be the mass of the entire compound. So one carbon with a mass of 12.011 plus 2 oxygens, each with a mass of 15.999. We're going to take that and multiply by 100% to get this decimal to turn into a percentage. So 12.011 divided by 12.011, that's the carbon in the carbon dioxide, plus the oxygen, 2 times 15.999, times 100%, or times 100 to turn that decimal into a percentage. And I get 27.292111479. Your calculator is going to give you a lot of numbers, and we need to know how to round. So my weights that I put into this equation have 5 significant digits. So that means that my answer should have 5 significant digits, 27.292%. All right, let's try another practice problem. What is the percent composition of nitrogen and nitrogen dioxide? So nitrogen dioxide is written as NO2. This is a covalent compound, so the Greek prefix is used to determine or to show that there are 2 oxygens for every 1 nitrogen in the formula. All right, and here is our the square boxes on the periodic table, so you can see the masses of each element. So our numerator is going to be the mass of all the nitrogen. There's only 1 nitrogen, but it's the mass of all the nitrogen. Our denominator is going to be the mass of the entire compound, so the nitrogen and the 2 oxygens. Then we're going to multiply by 100% to take that decimal and turn it into a percentage. So the nitrogen, 1 nitrogen times the mass of a nitrogen, 14.007, divided by 1 nitrogen times the mass of a nitrogen, 14.007, plus 2 oxygens times the mass of an oxygen, so 2 times 15.999, multiplied by 100%. And we type this all into a calculator. Keep in mind your use of parentheses for that denominator. You need to make sure that the entire denominator gets treated as one complete operation before you start taking the numerator divided by the denominator. Otherwise, you'll get the wrong answer because your calculator doesn't know the order of operations that you need. So we get 30.4466958 as our percentage. The masses that we put into this calculation have 5 significant digits each, and so our answer should have 5 significant digits. So our answer is 30.447%. That is the percentage of nitrogen by mass in nitrogen dioxide. So why don't you try this one on your own? I want to know the percent composition of each element in aluminum nitrate. Pause the video and try to solve it on your own. Okay, so the tricky part of this one is probably writing the formula for aluminum nitrate. Aluminum nitrate is an ionic compound. Aluminum and nitrate, they're both ions. When aluminum metal forms an ion, it has a charge of +3. So aluminum has a +3 charge. Nitrate is a polyatomic anion with a charge of -1. So when we combine the two, we're going to need 3 nitrates. That's why I'm putting 3 after the parentheses, after the nitrate parentheses. So we have 1 aluminum, 3 nitrogens in this, and 9 oxygens in this formula. So let's first calculate out the percent of aluminum. So 1 aluminum atom has a mass of 26.982. That's our numerator. Our denominator is going to be this entire compound. So there's a lot going on here. 1 aluminum with a mass of 26.982. And then we have 3 nitrogens. There's 1 nitrogen per nitrate, but there are 3 nitrates. So 3 times 14.007. Now our oxygens, there are 9 oxygen atoms in this formula. We have 3 nitrates, but there are 3 oxygen atoms per nitrate. So 9 oxygens times the mass of an oxygen, which is 15.999. What I'm going to do first when I do this calculation is I'm going to do the entire denominator first. And the reason is because I know I'm going to need that denominator number in future calculations. So rather than having to type in this whole thing multiple times, I'm going to figure out what that denominator is first. So the denominator, all of that bottom stuff, is 200, and I'll write this in here, 212.994. I'll come back to that and I'll need it. I'll use it later. The mass of just the aluminum, the 1 aluminum, is 26.982. And then I take the aluminum divided by the mass of the whole thing, multiplied by 100% to get my answer. So 26.982 divided by 212.994 times 100, oops, accidentally typed in 10. We'll times it by 10 again so that we get a value of 12.6679. Let's round that to 5 significant digits. So 12.668% aluminum in this compound. Now let's just go back and look at that denominator again. That denominator consisted of all the aluminum plus all the nitrogen plus all the oxygen. So when I determine the percent composition of the nitrogen, I already kind of have an idea of what I need for that. I need 3 times 14.007. So that's what I'm going to put as my numerator. That's all the nitrogen in that. So 3 times 14.007. I'm going to divide that by my previously calculated denominator. Remember I said I was going to come back to that 212.994, so I didn't have to type in the entire denominator all over again. So that denominator is 212.994. So the nitrogen represents the 3 nitrogens times 14.007, and the denominator is that 212.994. I will type all of this into my calculator, so 3 times 14.007. And then I'm going to divide that answer by 212.994, multiply by 100, and round to 5 significant digits because the masses that I put in had 5 significant digits. So 19.729% of this compound is nitrogen by mass. All right, our last one, oxygen. We have 9 oxygen atoms in this compound. Each oxygen atom has a mass of 15.999. I'm going to divide that by the mass of the entire compound, which is 212.994, and then I'm going to multiply by 100%. So let's type all this into my calculator. 9 times 15.999 divided by 212.994 times 100, 67.603. I'm going to round that one also to 5 significant digits, just because all of my masses that I have been using have 5 significant digits. So 67.603% of this entire compound consists of oxygen. Now, just a last step for fun and kind of just to do a check. I'm going to add up the percentages of all my individual elements and see if they turn out to be 100, which they do. It's exactly 100. So when you do this at the end, it doesn't have to add up to exactly 100%, but as long as it's very, very, very close, then you know that you did a correct job doing your percent composition calculations along the way. So that is how you do percent composition calculations.